Okay, so we're doing kinematics, and the first thing we start off with is displacement. Different than distance, in that we said it's kind of as the crow flies. So it's a distance from a point in a set direction. And the notation we use for displacement is S of t. We use S to represent displacement instead of d, so it doesn't get confused with distance. And the units that it's in, the units are going to be in distance. So I'm just going to keep it all metric here and say that it's going to be in meters. It can be in anything. It could be in centimeters or feet. Okay. All of these also are a function of time. Displacement, velocity, and acceleration all depend on one thing, and that's time. Okay, so as our example shows, if I've driven 3 kilometers and then took a right turn and drove 4 more kilometers, my distance is 7, but my displacement is 5. Okay, and I know I said it's going to be in meters, but the thing is it's just in units. It's not a rate. Displacement is not a rate. It's just simply units. So it could be meters or kilometers. Next up, velocity is the rate of change of the displacement. It's speed in a particular direction. Okay, we can't say velocity is speed necessarily, but it's speed with direction. And the notation we use for velocity, since it's a function of time, is v of t, and we usually do it in meters per second. Or we can write that as meters per second, like that. Finally, if we go one more, the rate of change of velocity is known as acceleration. All right? So the notation for acceleration is a of t, and the units we use for acceleration, meters per second squared for acceleration. Meters per second squared, or if you want to write it fancy, we can use negative exponents. Okay. So that's all right. We've got displacement, velocity, acceleration, and how are all these guys tied in together? So what holds all this together is calculus. All right? If we want to bounce from a displacement function to a velocity function, we're going to differentiate. We're going to derive the displacement function to find the velocity function. And if we want to go from velocity to acceleration, we're going to differentiate that function. And so the opposite of that is going to be true as well. If I want to go from acceleration to velocity, I'm going to do the opposite of differentiation, which is to integrate or anti-differentiate. Okay? So calculus is what ties all these things together. And just some notes. First of all, I've already mentioned that all expressions are going to depend on time. Since we're dealing with calculus, a lot of these are going to have equations that are set to 0. And the word initial is going to mean when time is 0 before it started. So initial displacement is t equals 0, and initial velocity is t equals 0 as well. Now, remember, with calculus, when I'm finding the maximum and minimum, that's when the gradient function is set to 0. So the maximum and minimum displacement of an object, it's been derived, so that's when we set it equal to 0. The velocity function is set to 0 if we're finding the maximum or minimum displacement. An object at rest. Okay? An object at rest, maybe when you throw something up in the air, and the maximum point when it's not slowing up or slowing or speeding up is when we set the velocity equal to 0 as well. So object at rest, velocity is 0, which means we set the velocity function equal to 0, and we'd be solving for t. We'd be solving for time. Now, object at a constant speed, what does that mean? It means its acceleration is 0. And so we would set the acceleration function equal to 0 and solve for t if we were doing that. Okay, and two other things. If an object's slowing down, then acceleration is negative or less than 0. And also if an object is traveling back to its initial position or its initial starting point, then our velocity is negative. Our velocity is negative if it's because velocity depends on direction. If it's traveling back to its initial place, it's going to have a negative velocity. Okay, so now we'll do some problems. Okay, so first example is displacement upwards of a ball is given by this displacement function, and find v of t means find the velocity function. What's the velocity function? So to do that, what do I'm at displacement and I want velocity. You're either going to have to ask yourself, am I differentiating or anti-differentiating? So we're just going to have to remember this. I'm differentiating here, so the velocity function is this differentiated. 60t differentiated is 60, minus 5t differentiated is minus 10t. And if I want to put the units there, I can, and I can just say that's in meters per second. Okay? Next one's find the acceleration function, and again, refer back to the notes. That means I'm going to differentiate the velocity function, which I just did. And that acceleration function is going to be this differentiated. 60 differentiates to 0, and negative 10t differentiates to just negative 10 meters per second squared. Our acceleration is negative. What does that mean it's doing? It's going to be slowing down if it has a negative acceleration. Now the next example, it's kind of a silly equation question because there's find the acceleration at t equals 4. So I go back to my acceleration formula, but there's not much of a formula there. Because there's no variable there, there's nothing to substitute. So the acceleration at 4 seconds is just going to be this right here, negative 10 meters per second squared, because I have nothing to substitute it into. Okay, next example. Displacement function we have right here. Find the displacement at the initial time, t equals 0, 6 seconds, and 12 seconds. No calculus needed here. I just substitute each of these into my displacement function. So I'd say S of 0 is negative 48 times 0 plus 4 times 0 squared. And after I substitute all that in, that will give me my displacement in meters. So at 0 seconds, it has gone 0 meters. What about at 6 seconds? What's the displacement after there? Substitute 6 in for t into my equation. And I think I get negative 144. I do get negative 144 meters. And we'll talk about what that means in a minute. We can get that when we're talking about displacement. We can get a negative value there. That's okay. All of these negative values have meaning. And finally, after 12 seconds, so next step, find the velocity for the same seconds. That means we're going to differentiate my displacement function and substitute these three values in for them. Let's differentiate it first. This differentiated is negative 48 plus 8t. And I just substitute each of these values in for that and find out what it is. V at 0, negative 48 meters per second. Remember what a negative velocity means. And finally, the velocity at 12 seconds, substituted into the velocity formula. Okay, so those are just some examples, and the rest of them with acceleration mainly we're going to have to do on another day. All right, that's it to get us started for now.